Hello guys, welcome to Tariq's class. So today we're gonna do geometry. So question number 1, it says 3 circles with centers at point ABC touch each other externally. As you can see, if the radius of the circle with center A is 6, so let me zoom in a little bit. So radius of the circle A is 6 and the segment BC is 9. So this is 9. So 9. And what is the perimeter of the triangle ABC? Okay, so as you can see, I'm going to use different color for this. So I know that the radius, one of the radius of center B and one of the radius of center C makes 9. But how much is each? We don't know. But the other radius of center B and other radius of center C will make another 9 as well. And the radius of center A is 6. Now that together makes the perimeter of the triangle. So this is 9, this and this part makes 9, and 6 and 6. So 9 plus 6 plus 6, that's the perimeter of the triangle. So that's 18 and 12, that's 30. Okay, so what we can do is we see that the side length was 8 by 8, right? So the radius of this circle will be half 4. So let's say this is 4, 4, 4, right? This is 4, the other part is 4. Now this is also a radius, that's a 4. So what we can do is, well, we make an isosceles triangle here. So I can say x by 4. It's a baby triangle, right triangle. We can use Pythagorean theorem. X squared plus x squared equal to 4 squared, right? And that would have been 2x squared equal to 16. So divide both sides by 2. So x squared equal to 8. Square root. So x equal to square root of 8. Now the side, it was shown that square root of 8 means square root of 4 times square root of 2, which is 2 radical 2. Okay, simplifying radicals. So x is 2 radical 2. That's this part of the square, the baby square. That's what we're looking for. Now other part, this is same as the 4. Remember, you see 4. So this whole thing is x plus the 4, which is x is the 2 radical 2 and the plus 4. And that would be the full side length of the smaller square. So answer is 2 radical 2 plus 4. Yes, C is the answer. Number 3, all the vertices of the quadrilateral math are on the circle. If the measure of angle A is 87, so this is 87. What is the measure of angle H? So we're looking for how much is that. Now first of all, this is a quadrilateral, so all 4 angles will be add up to 360 degree. Actually, what you can do also is take a look at this. First, you got to learn what inscribed angle means. So if I draw an angle here on the circle, any point on the circle, this will be half of the related arc. So let's say this part here is 70 degree. This angle would have been 35 degree, the half. So similarly, so when you have a full circle, and here if I draw a diameter passing through the center, so any angle here would be half of the related arc. Half of the related arc for this angle is this whole thing, which is 180 degrees. So this is a 90 degree. All of them will be 90. So that's how it works. So similarly, if you take a look, so this angle here, 87, if you draw, it covers the arc from here to here, okay? And this angle here, H, that covers, so it covers the arc of this one. So technically they cover the full circle, right, which is 360 degree, and half of 360 is 180. So the rules, one way to remember it is if the quadrilateral is inscribed, the opposite angles will always add up to be 180. Okay, so the A here 87, the other one will be 180 minus 87, which is 93. So this will be 93. So, and these two will also be add up to 180. The diagram above shows a circle with the center at point W. A segment FG touches the circle at point F. So FG is touching. So this is a 90 degree. Remember that. A tangent is line that is touching the circle once, and a radius, it always makes 90 degree. So if you draw any tangent and radius will always make 90 degree. So I know this is a 90 degree right triangle. Now, if the triangle EFW is the smaller, EFW is the smaller one, is equilateral, so all these sides are equal. What is the measure of angle G? So equilateral means each angle here is 60, 60, 60. Remember I told you this is 90. So the small baby part of it, it'll be 90 minus 60. So 60, that's a 30. And remember this is straight line makes 180. If that's 60, that's 120. So this is another triangle EFG. It's a small triangle which has one angle 30, another 120. So the third angle will be 180 minus, what is 120 plus 30? 150. So answer is 30. So this angle is 30 degree. So B is the answer. So G is angle 30. Number 5. So the diagram above shows a circle with the center at point P. A shaded part of the circle forms 15%. So this is 15% of the entire circle. What is the angle measured by this shaded sector? Okay, so 15% means 15 over 100, right? If I simplify by 5, it's 3 over 20. So 3/20th of the circle, right? Now, what you can do is, they said in terms of angles, what is the angle? You know that the full circle is 360 degree. So 3/20th of 360 would be how much? So, you can use calculator, but I know 0 gets out. So this is 18. It's 54. And so it'll be B. 6. A circle has a radius 12. So we're going to draw the circle, radius 12. What is the length in unit of an arc that spans a central angle of 30 degree? So this is a 30 degree central angle, right? Now they said, what is the arc in terms of pi, like radians? So first of all, let's find the total circle, the circumference of this circle. Circumference you find is, you remember the formula? Pi times the diameter. So radius is 12, diameter would be 24. So 24 times pi. That's the full circle. But they wanted 30 degree. Well, 30 degree out of 360 is what fraction? It's actually 1/12th, right? 1/12th of the circumference. So 24 pi, I'm going to times it by 1/12th. That's 2 pi. So answer is B. Number 7. The point -6, 8 lies on the circle with the center at the origin. So origin is here, x coordinate, y coordinate, right? Origin, and the point -6, 8, let's say -6, 8, somewhere here. It lies on the circle. Okay, so what is the area of this circle? So area of the circle is, this is the radius, right? How do you find area of a circle? It's pi times the radius squared. So first of all, in order to go to this point, we had to go -6 to the left. So 6 is this, the distance of this line, and we have to go up 8, right? It's a right triangle. We can use Pythagorean theorem to find what is this length of this radius, because the circle, remember, it's passing through something like this. So now this radius, we know that it's 6, 8, 10 by Pythagorean triple. If you don't know the triples, you can use the Pythagorean theorem. So 6 squared equal to plus 8 squared equal to x squared, which is 36 plus 64 x squared. So that's 100 x squared. If you square root, x will be 10. Okay, so I know the radius is 10. So pi times 10 squared. So it will be 100 pi, the area of this circle, D. Question number 8. It gave us an equation in the xy. The graph of the equation above touches the line y equal to a, where a is a constant. What is the largest possible value of a? So what kind of equation is this? We know equation of a line looks like y equal to mx plus b. Quadratic equations looks like y equal to ax squared plus bx plus c. Now equation of a circle actually looks like this. X minus h squared plus y minus k squared equal to the radius squared, where the center is considered the h and k, and r stands for radius. Let's learn one of them. For example, I'll give you my own example. So x plus 5 squared plus y minus 2 squared equal to, let's say, 9. Now what is the center? It would be, you always switch the sign because they're supposed to be a minus, but it became a plus. So one trick is, whatever in front of the number, the h, you switch the sign. It's a plus 5, we take minus 5. It's a minus 2, we take plus 2. And radius on the other side, remember, you have to square root it because the other side is radius squared. So square root of 9 is 3. If 9 were to be, let's say, 12, you cannot square root. The answer will be square root of 12. Okay, so that's the basic behind this question. Now let's come back to the question. The question says in the xy plane, the graph of the equation, which is a circle, will touch a line y equal to a. Now where a is a constant, what is the largest possible value of a? First of all, let's find the center of this circle. Remember, this is a plus 6, so it will be minus 6, comma. Instead of minus 3, you write 3. So that's the center. And the radius, you have to square root the 196, it will be 14. So whatever the circle is, it's going to go negative 6 up 3. This is the center. And it will have a radius of 14. So 6 and more. So let's say here, 6 plus 8 would be 14. So it will be 8. So something like this. Okay. So that would be the drawing of the circle. Now y equal to a, it's a horizontal line. For example, if you have y equal to 5, there will be a horizontal line passing through the 5. If y equal to 3, it's a horizontal line passing through the 3. But now it says y equal to a, we don't know. They said, what is the largest possible value of a? So if you want to do that, so the possible value of a, y equal to a, could be the largest possible, something like this, right? Y equal to a. Get it? So this is on the up and touching the circle because they said the graph of the equation touches the line. So y equal to a will be on the top. So from center, if you go up, remember the center was what? Negative 6 and 3, right? Now 3 is the y coordinate. So if you go up, how much up do you have to go? You can only go the radius, which is 14. So 3 plus 14, 17. So this line will be y equal to 17. Okay, so the center was negative 6 comma 3, and y equal to 17 will be a line. It's like touch it one time, and that's the highest. If you bring down the line more, the horizontal line, it will be less and less. But they said, what is the largest? Okay, question number 9. They said this is an equation of a circle, but it looks in a different way. So we cannot tell what is the radius. But they said, what is the area of the circle? Area of the circle is pi times radius squared. We need to find the radius. So I typed it in to the Desmos, and I see the 2 points here. One is 3 comma 3, another 3 comma negative 15. So these are the two endpoints of the diameter. So you see y coordinate 3, go down to negative 15. So 3 to 0 is 3 plus negative 15, which is 3 and 15 is 18. 18 is the diameter, guys. But we need the radius. Radius is 9. So pi times 9 squared. So that's 81 pi. So Desmos helps. Number 10 is interesting. So take a look at that. So this is 8, a comma 8. This is a comma 1. So that's the distance is 7 unit from 1 to 8. So the side length of the square is 7. Now, if you look, this is 0.7 comma something, right? The x coordinate is 7. X coordinate is a. So remember the distance is 7. So if I go back 7 units, a will be 0. Because 0 to 7 is 7. So a is 0. Okay. And now how do we find B and C? Well, since I know A is 0, is 0 comma 1, B is the midpoint of this and this. So midpoint of 0 comma 1 and 7 comma 8. How do you find midpoint? If you want to find midpoint, you see the x coordinate of the first pair plus the x coordinate of the second pair. So 0 plus 7, that's 7 divided by 2. So that will be 3.5. So that's the x coordinate of the midpoint. So B is 3.5. How do I find C? C will be the sum of the y coordinates, which is 1 plus 8, divided by 2. So that's 4.5. So C is 4.5. Now we know, they say what is the sum of all of it. So 3.5 plus 4.5 plus A was 0. That's 8. A is the answer. So whatever formulas you're learning when I'm going over these questions, the purpose is that you write them down on a notebook and then you study them back and forth. Try the questions again. If you forget, look into the video again. Number 11. In a triangle ABC, C is the right angle. Okay. C is going to be right angle. A and B are the other 2 points. Now, AB is equal to 2BC. So whatever the BC is, let's say X, AB is twice. Which of the following statement must be true? Now, one thing you have to understand, this happens in a situation in right triangle only if you see it's a 30, 60, 90. So in 30, 60, 90, that will be given in your reference. So you're going to see whatever the line across from 30, the line across from 90, the hypotenuse will be twice. So I know that this is 30-degree angle because that's the line across from 30, which is X, and the hypotenuse is twice. And this is going to be 60-degree, of course, because 3 angles have to be add up to 180. Now, if you look back at it, so the other side will be X radical 3. So this will be given in the reference table. It's called 30, 60, 90 special triangle, and you just follow the pattern. So across from 60 will be what? If you say it's X radical 3, right? Now, which of the following statement must be true? AC equal to BC. Well, that's not true because AC is X radical 3 and BC is X. AC is equal to square root of 3 over 2AB. AC is equal to square root of 3 over 2AB. Okay, I'm going to come back to it later. So angle B is 30 degree. That's not true. Angle A is 2 times angle B. A is 2 times angle B. That's correct. So D should be the answer. But I don't think B is going to work. But if you want to check it out. So AC is equal to square root of 3 over 2AB. Now remember, AC is X radical 3, square root of 3 over 2, and AB was 2X. Now, if you divide by radical 3 both, it will be gone. So, and 2 divided by 2 is just 1. So, X equal to X. Okay, this actually works. So, angle A is equal to 2 times angle B. Oh, no. D is not going to work. Sorry. Angle A is actually half of angle B. So, B is the answer. D is not the answer. Sorry about that. Number 12. The diagram above shows 2 similar triangles, SAT and Fox. Now, in which the angles S and F and A and O correspond. So, S and F, A and O will correspond. Means they will be the same angles because when 2 triangles are similar, their corresponding angles are equal. If the measure of angle S is 82, so this is also 82. And the measure of angle X is 38. So that will be 38 as well. What is the measure of angle A in radians? Okay, let's find in degree first. So first of all, 3 angles of a triangle add up to 180. So if you want to find this, you add 82 and 38. Right? So that's 0, 120. Now, is it actually 120 or... Yeah, so 120, you subtract it from 180, so you get 60. So that will be 60 angle A. Now 60 degree, how do you make a degree into radians? Now radian, the value of radian is pi equal to 180 degree. So you want it in terms of pi. So I'm going to multiply the 60 by pi over 180. Because pi over 180, pi and 180 is the same thing. So 60 and 180 simplifies to be just 3. So it's pi over 3. And also you can see that pi means 180. So B, 180 divided by 3 is 60 degree. So B is the answer. Welcome to Tariq's class. This is Geometry Part 2. We're going to learn more about geometry in SAT. Now, question number 1. In the trapezoid ABCD, you can see the trapezoid ABCD, base BC and AD have length 12. So BC and AD have length 12 and 20. So this is 12, that's 20. AD is of course longer. Point P lies on the ray BC. P is on the, it's over there. If the line AP, okay, AP is this longer line, this divides the trapezoid into two figures with the same area. So this is dividing the trapezoid means this part of the trapezoid will be equal to this part of the trapezoid, means same area. Now what is the length in centimeter of the segment CP? So this is what we're looking for, CP. Okay, let's find the area of the trapezoid first. So I know the area of the trapezoid formula is base 1 plus base 2 times height divided by 2. Now we have base 1, 20 plus 12, but the height we don't know. Okay, height, let's say this is the height. I'm going to call this height anything, let's say H. I'm going to call it H. So times it by H. So it's 20 plus 12, 32 divided by 2, 16H. That's the area of the trapezoid. If you divide it by 2, so 8H. So this part is 8H, the red trapezoid. This is going to be 8H. And this triangle here is also 8H. Remember this green shape, it's a triangle, and the red shape, it is a trapezoid. Now, if you look carefully, at this point I'm going to call it M, so you understand what this point is, because every other point is labeled. Now, what we know about a triangle, so by the way, the triangle, the height of the triangle is, we don't know, but we know that the area of the triangle is equal to half base times the height, right? Now here we know the area is 8H, half, the base is 20 of this triangle, and the height, we don't know. Height, I'm going to call it, let's say Y. Just this is Y, the height of the triangle, okay, Y. So the Y will be 8H equal to 10Y. So Y is equal to 8 over 10, that's 4/5 H. Okay, so that's the height of the triangle, this one. Now other baby triangle here, so this triangle and this two triangle, they are actually similar. Similar triangle means they have same angle. Like for example, their vertical angles are equal. This angle is equal to this because of alternate interior angles. When two lines are parallel, you know, the Z, the alternate interior angles are equal. So when two angles are equal of the two triangles, it means they're similar. So the height of this one is here. I'm going to draw. This is the height of the baby triangle. But one thing, if you notice, the height of this big triangle and the baby triangle is equal to the height of the big trapezoid. Okay, now I'm going to set up a proportion. The proportion is going to be, because the two similar triangles, I'm going to write on this side. Well, the base of this triangle is 20, so I'm going to write 20 here. And the base of the other triangle is CP, which is X. Okay. Now the height of the big triangle, we found out that's 4/5 Y. Now what is the height of the smaller triangle? Remember the full trapezoid, the height is what? We picked H, right? That was the full trapezoid. So if you want to find the height of the rest of it, the triangle, I can do whatever the full height of the full trapezoid minus the height of the smaller triangle. So for example, okay, sorry, it was 4/5 h. Now the height of the smaller triangle will be full height of the trapezoid, which is h, minus the height of this triangle, which is 4/5 h. So 1 minus 4/5 is 1/5. So 1/5 h, that's the height of the baby triangle. So here h and h cancel out. Now you can cross multiply. So 4/5 x equal to 1/5 of 20 is 4. Now times it by 5/4 both sides. We're just solving equation now. So this cancel out, these two. So 4 and 4 cancel out. 4 divided by 4 is 1. So x is equal to 5. So the answer is 5. So just to understand it better, let me just quickly give you this part quickly. So how I made the proportion. So whatever the height of the trapezoid was, the height of this triangle plus height of this triangle adds up to be that. That was h, and this was 4/5 h, and that was 1/5 h. So that was the ratio we used. And this was the base of this triangle, base of the triangle. So we made a proportion out of this triangle and this one. The base over the base, height over the height, and the trapezoid height helped us do it. I'll say look into the video a couple more times and try to make sense out of it. Do more practice. Number 2, each exterior angle of a rectangular polygon is 30. How many sides does the polygon have? Oh, sorry, it's a regular polygon. So regular polygon, each exterior angle is 30. So any polygon, right? Any polygon you add, I'm just going to put one of them, let's say a square. Exterior angle is the angle that makes 90 with the interior angle. So each exterior angle of a rectangle or a square would be 90, 90. Exterior means outside. 90, 90. All 490 adds up to 360. Now let's take another example. Let's say a triangle. Each angle, let's say 60, 60, 60. Regular means each sides are equal. So angle next to it will be 180 minus 60. Which is 120. If you extend this one, 120, you have to extend it, 120. So remember, interior and exterior, they have to be add up to 180. Now, 3 120s add up to be 360. So what do you understand from it? No matter what kind of polygon it is, if it's a regular polygon or anything, all the exterior angles will be add up to be 360 no matter what. Always 360. So I divide 360 by 30. So 0 cancels out. It's a 12-sided polygon. So A is the answer. Question number 3. The area of a square ABCD, as you can see, the square ABCD, constructed on the hypotenuse of the right triangle CED. You see, this is the hypotenuse of this triangle. And is 256. Okay, so area of this square is 256. So they're talking about the area of the square ABCD constructed on the hypotenuse of the right triangle CED is 256. What is the length of the side DE? DE. Okay. First of all, it's a 30, 60, 90. Remember, it's a right triangle 30, 60, 90. So what do you remember about it? This will be given on the reference table 30, 60, 90. So whatever is across from 30, we'll call it X. The hypotenuse will be 2 times that. And across from 60 is x radical 3. Now square root of 256 is how much? Is 16. So each side is 16. So this side is 16. Remember, the angle across from 90 is actually 2x. So 2x, if you look at the pattern, there will be 16. So x is actually 8. So across from 30, that's a different x. So this is 8. Across from 60 will be the one with the radical 3. So it's going to be 8 radical 3. So answer is B as in boy. The surface area of the hollow cylinder means the top and bottom is open. It's like a pipe. Is 128 pi. Okay, so surface area is 128 pi. The formula for the surface area of a hollow cylinder is just 2 pi r times the height. This one you should remember. Now radius and the height. So surface area is 128 pi, 2 times pi, and the radius and height, let's see what they said. If the diameter of the base of the cylinder is 200% times the height. So let's say height is x, the diameter will be 2x, but we're dealing with radius, so radius is again x. So radius is x, height is x. So 2 pi x squared equal to 128 pi. Now divide both sides by 2 pi. So x squared equal to pi cancels out, that's 64 if you square root. So x equal to 8. Okay, now they said what is the volume of this cylinder? Volume is pi r squared times height. So pi times the radius is 8 squared times 8. So that's 64 times 8, that's 512 pi. So answer is D as in dog. So these are like a 3-dimensional shape. So it says the 2 diagonally opposite vertices of a cube. So I can call it like x, y, and z, x1, y1, z1. This is x2, y2, z2. I'm just going to find the distance of this diagonal. So distance formula is same. So square root of x2 minus x1 square plus y2 minus y1 square. We're just going to add this z2 minus z1 square, you know. So here, let's do the 7 minus 2. You can do either way, it doesn't matter. Plus y2 is 1 minus negative 4. That's 1 plus 4 squared plus, that's going to be z2 is 0 minus 5 squared. Now this is 7 minus 5, 5 squared 25. That's 5 squared 25 and 5 squared 25. So it's square root of 75, which is, if you simplify 25 times 3, so 5 radical 3. So 5 radical 3 is the diagonal of this cube. So you know how square works? If two sides are x and x, the diagonal will be x radical 2. That's the 45, 45, 90 rules as well. So similarly in the cube, if each sides are 5, 5, 5, that's when the diagonal will be 5 radical 3. Just remember this trick. So I know each side is 5. Now what is the volume of the cube? So it's 5 cubed, that's 125. Number 6, a right triangle with a smaller leg 5 centimeters, so this is 5, and the hypotenuse of 13 is rotated about the larger leg. So you see the rotation happening here. So if it rotates, this is going to end up making a cone actually. Yeah, it's going to make a cone if it's rotating around there. Okay. So now, what is the volume of the cone? The cone volume will be given, but remember 1/3 pi times r squared times the height. Now 1/3 pi, and the radius is 5 squared times the height. This is a slant height, remember that. This is not the original height of the cone. The original height is this one, which is part of this right triangle. It's 5 by 13. So if you know the triple, it's a 5, 12, 13. But if you don't know about it, you can use Pythagorean theorem. That let's call this height h. So we can do x squared, which is 5 squared plus h squared equal to 13 squared, the hypotenuse. So h squared equal to, that's 169 minus 25. So h squared equal to 4. 9 minus 5 is 4, 6 minus 2, 4, 144. So if you square root, h equal to 12. So that's the height of this cone. That's what we're going to use. If you calculate it, so that's 1/3 of 12 is 4. 4 times y is 100 pi. So the answer should be A. Number 7, the surface area of the sphere. Okay, sphere is different. Okay. With the radius r, radius is r, is given by the formula s equal to 4 pi r squared. Which of the following shows the radius of the sphere in terms of surface area? So they just want you to solve for r. So s equal to 4 pi capital R squared. So first we can just divide by 4 pi both sides. So r squared equal to s over 4 pi. Now we square root both sides. So r equal to square root of s stays inside. Square root of pi, we don't know. So this 2 stays. But square root of 4 is 2. So remember, but that's in the bottom. So it's 1/2 square root of s over pi. Make sure the 2 is in the bottom denominator. So 1/2 square root of s over pi. So B is the answer. Number 8. A ceramics supplier packs clay in sacks weighing 2.5 kilometers each. I'll just underline that. A total of 380 sacks need to be shipped to a pottery studio. Now the shipping crates used can hold up to 110 pounds. Okay, so how many crates will be needed to ship all the sacks? So it's just conversion. So 2.5 kilogram in each of these sacks, and there are 380 sacks. So times it by 380, so the answer will be 950 kilogram. And now 1 kilogram is 2.2 pounds, so 950 kilogram will be times 2.2, that's 2090 pound. Now each crates can hold 110 pounds, so 2090 divided by 110, the answer is 19. So C, this one is an easy one. Number 9, a remote controlled car travels 161 meters in 24 seconds. Okay. What is the speed in miles per hour? So that's meter 24 seconds. Okay. So we want the miles per hour. So I'm going to multiply by 1 mile is 1610 meters. So I'm going to write, so meter and meter, I want it to cancel out. So 1610 meter and 1 mile. So technically I'm just multiplying by 1. Okay, because 1 mile is same thing as 1610. The reason I did it, so it cancels out the meter and the mile will stay. Now they want in terms of hours, they don't want seconds either. So I can multiply also that 1 hour is equivalent to 3600 seconds. In that way the second will now cancel out. You see, one in the numerator and the denominator. So technically all I have to do is multiply this 3600 with 161, and that will be the numerator, and the bottom will be 24 times the 1610. Well, 161, this is just 1 over 10 if I simplify it. You can use calculator, of course. And the 0, 10, this is just going out. So 360 divided by 24, use calculator for that. Answer is 15A. Okay, number 10. So we're learning this, the complex. So I is equal to square root of -1. Okay. So we're dealing with I squared and I power 3. So I squared would be, if you square the square root of -1, this is -1. And I power 3 would be what? I power 3 is just, remember, it's I times I squared. And I means square root of -1. And I squared we found is -1. So that's just negative square root of -1. That's what I3 means. Now let's just plug in. Let's see how it looks. So 7, which is negative I, you can just call it like negative I. Okay, you can also do that. So in this case, let's start plugging in. So 7 times I cube means negative I, plus 12 times I square means -1. And I'm just going to erase this for now here, and I'm going to write it on the side. So we found I is equal to square root of -1, which is given. I square is -1, and I power 3 is negative I. Now 12 times -1 minus 8 times I means what? Square root of -1. You can call it, or just let's keep it I for now, equal to 4I minus 12. Okay, now this is -7I minus 12 minus AI equal to 4I minus 12. So if I do plus 12 both sides, the 12 cancels out. So I have -7I minus AI. I can do minus 4I both sides, minus 4I equal to 0. And I can just factor out the I here. Before that, -7I and -4I is -11I minus AI equal to 0. Now I can just factor out the I. I get -11. Let's factor out -I. I get 11 plus A equal to 0. Oh, I can just divide both sides by -I. So that's gone. So 11 plus A is 0. So minus 11 both sides. A is negative 11. Okay, so A is gonna be negative 11. So B is the answer. Number 11. So if the above complex number is equivalent to A plus BI, what is A and B? So first of all, you see 3 plus 4i and 3 minus 4i. This kind of work like, remember A square minus B square, the difference of 2 square was A plus B times A minus B, right? So the point is, we do not want the I in the denominator, So only way a square root, because I is the square root of negative 1, will be gone if I can bring in a square. So square can come in if I can make a pair like a plus and a minus. So I'm going to multiply by its conjugate, that's what it's called. 3 minus 4i, I'm going to multiply top and bottom by 3 plus 4i. Because the bottom, remember we don't want square root in the denominator. So bottom we have, A minus B, A plus B. So 3 minus 4i, 3 plus 4i. So I can write it as 3 squared minus 4i squared. Remember from here, this reference. Now that's going to be 9 minus, on the top is just 3 plus 4i, 3 plus 4i. So same, so 3 plus 4i squared. We'll come to it later. So 3 plus 4i squared on the top. On the bottom, 9 minus, that's 4i is 4 squared is 16i squared. Remember, I means square root of negative 1, but I square means negative 1 if you square both sides. So I can plug that in here. So I get 3 plus 4, again I'm going to write it here. So 3 plus 4i squared over 9 plus 16, which is 25. Now they said they wanted in terms of A plus whatever. So I'm going to expand the 3 plus 4i squared. Let's expand it on this side. First of all, you can do it in a FOIL way. But if you know the completing square, so it's just going to be 9 plus 24i plus 16i squared. Okay. So I square means again negative 1. So it's 9 plus 24i minus 16. So 9 minus 16 is 24i minus 7. So it's 24i minus 7. That's the numerator. So I'm going to write it here. So 24i minus 7 over 25. Right? Now they said, what is A plus B? If I were to write it in this form, A plus BI, so I will say negative 7 over 25, that's A. I'm going to separately give them A, plus 24i over 25, that's B. You see, A plus BI. So A is negative 7 over 25, plus B is 24 over 25, which is 24 minus 7 is, how much is that? So that will be for 17, I guess, 17 over 25, which is, if you use calculator, 0.68. It's a pretty simple game, to be honest, like this. The main part is this, making it, you see 3 minus 4i, 3 plus 4i, and then you just use the technique. This is just, dots, and the top, you just have to multiply the FOIL. And at the end, this is another part you have to be careful. I separated them, divided both by 25. So I can make it look like A plus BI. So I can see which one is A and which one is B. Number 12. In the right triangle ABC, cosine of x equal to 0.8. If the length of BC is 9, what is the perimeter of the triangle ABC? So first of all, the SOHCAHTOA. So cosine works with adjacent over the hypotenuse. Well, 0.8 can be written as like 8 over 10. Now, if I say adjacent is 8 and hypotenuse is, this is the opposite, so 8 and 10, but it doesn't work with the 9. So we have to come up with an idea. We're going to call it 8x. Actually, I can simplify it more. So that's 4 over 5. I'm going to call it 4x, this one 5x. Now let's use the Pythagorean theorem. So 4x squared plus 9 squared equal to 5x squared. The reason I put x because it's a ratio that's given. They didn't give us the original. So I multiplied by x something. So that's 16x squared plus 81 equal to 25x squared. So now I can minus 16x squared both sides. So 81 equal to 25 minus 16 is 9x squared. It's turning out to be nice. Now square root both sides. So you can divide by 9 first actually. That'll be easier. 81 equal to 9x squared. Divide by 9. Divide by 9. So x squared equal to 9. Square root x equal to 3. Here we're not going to take the minus because we're doing geometry. The side length cannot be negative. So x equal to 3. So I'm going to plug it in back. So that's 12 and 15. Now they said what is the perimeter? So 12, 15 and 9. So 12 plus 15 is 27, 36. 36 is going to be the perimeter of this triangle. Alright, question 13. It says in the right triangle mat, which is the whole thing, TH is the height. I can see that. Now, drawn to the hypotenuse of hypotenuse. Okay, so this is hypotenuse. Now, angle A is A. Now, TH is H. Now, in the terms of A and H, what is the area of the triangle? So, we have to find the area of the triangle. But if you look at the options, all of them have like a sine and cosine. So, we have to bring both. So, we know that it's half base times height. This is the height of the right triangle. This is the base. Now we just have to find it and plug it in. Now let's find the height. So here, this one, what is this? Let's call it x. We'll call it y. So first of all, x, remember in terms of a and h, so we have to find out. So I can say opposite. Okay, if I look at this triangle here, this is the opposite from a and this is the hypotenuse. So I can use sine, you know the SOHCAHTOA. So sine angle A degree, which is equal to opposite h over hypotenuse x. Now if I cross multiply, h equal to x sine A. Now if I divide both sides by sine A, now I know x is h over sine A. So that's what I'm going to write here. You know, h and a is fine. So I have one part. Now I need to find the area of the big triangle, right? So what I need is, here I need to use cosine as well because all of the options is cosine. So cosine of A would be adjacent over hypotenuse. In the big triangle, this is the right triangle. So adjacent would be the h over sine A. This is the adjacent. And the hypotenuse is this one, which is, I don't know, let's call it a y. Now, if I cross multiply, so y times cosine A equal to h over sine A. Now I can just times it by 1 over y, both, sorry, we're solving for y. So I can times it by 1 over cosine A both sides. So cosine cancel out here. So y equal to h over sine A times cosine A. And that's this one. Okay. For area of the triangle, I can also use this as a base and this as a height. Okay. So I'm going to do, the base is this, which is h over sine A times cosine A. The height is just height. So it's h squared over sine A cosine A. Do we have something like this? Oh, sorry, half times that. So yeah. So we have h squared over 2 sine A cosine A. Yeah, option B works.